What if I told you that the solution to one of modern AI's biggest, most critical flaws wasn't found in some futuristic computer lab, but in a system of logic that's been around for over 2,500 years? Well, that's exactly what we're going to dive into. The absolutely fascinating story of how researchers are looking to the distant past to teach AI how to truly reason. So here's our game plan. First, we'll break down the big problem with AI today, what I'm calling the illusion of thinking. Then we'll travel back in time to find a pretty wild answer from ancient India. We'll look at the intense 6-step workout they put the AI through, check out how they tested it, and then uncover the seriously surprising results. Finally, we'll talk about what this all means for the future of AI we can actually trust. All right, let's kick things off with a fundamental weakness in today's AI. For all their incredible power, these large language models are basically masters of pattern matching. And because they're so good at it, they can create this really convincing illusion that they're actually thinking. And look, this isn't just a theory. Get this, it's a bombshell finding from Apple's own research team in 2024. They discovered that if you just throw a simple, completely irrelevant detail into a math problem, the AI's performance can absolutely plummet. This isn't just a tiny bug, it's a crack in the very foundation of how these things reason.
Yeah, just let that number sink in for a second. A 65% drop in performance. That's massive. It proves the AI isn't really understanding the problem. It's just matching patterns. And when a new pattern throws it off, the whole thing comes crashing down. It's like a house of cards.
The experts have a name for this. They call it the epistemic gap. It's a fancy term, but it boils down to this. The AI can't tell the difference between a fact it knows for a good logical reason and an answer that just feels right based on all the data it's seen. It doesn't know how it knows. And that gap, that's what we need to close if we're ever going to truly trust AI. So how on earth do you solve a problem like that? Well, this is where our story takes a turn. To bridge that epistemic gap, researchers looked to a very unexpected place, Navya, a system of logic from India that's been refined for thousands of years. And this isn't some forgotten philosophy they just dug up. Its foundations were laid way back around 500 BCE. It was formally systemized around 1325, and now, almost 700 years later, it's being integrated into our most advanced AI. A 2,500-year-old framework is literally getting a new life inside of a silicon chip. How cool is that? So what's so special about it? Well, here's the key difference. A lot of Western logic can get super abstract, all symbols and theoretical proofs. But Navya is different. It's grounded. It demands that every single step of your argument is tied directly to explicit, verifiable evidence. It forces you to show your work, which is exactly what modern AI can't do.
Okay, now for the really fun part. How do you actually teach this ancient system to a machine? Well, you don't just feed it a textbook. You put it through a rigorous, 6-step cognitive workout. It's designed to build genuine reasoning muscles.
Think of these 6 phases as a complete mental scaffolding for the AI. It has to start with doubt, really analyzing the question. Then it has to identify all the sources of evidence. It builds a formal 5-part argument, stress tests that argument with what-if scenarios, checks itself for logical fallacies, and only then does it reach a final, justified conclusion. You can't skip a single step. And let's zoom in on the heart of this workout, because it's really the engine of the whole thing, the Pancha Avayava, or the 5-member syllogism. This is way more than just A plus B equals C. It forces the AI to act like a lawyer building an absolutely airtight case for a jury. You state your claim, you present the evidence, and then, this is crucial, you cite the universal rule that makes your evidence relevant. And this part right here, this is the secret sauce. The universal example step is a total game changer and forces the AI to not only state a general principle, like wherever there's smoke, there's fire, but it also has to provide a concrete, real-world instance of that rule. This is what stops the AI from just matching abstract patterns. It has to ground its logic in reality.
Okay, so this all sounds great in theory, right? A logical workout from antiquity, but does it actually work in practice? Researchers set up an experiment, which they called Pramana, to see if a modern AI could really learn to think this way.
They did it in 2 stages. They started off small, with a less powerful model and a tiny dataset of just 20 examples. Then, for stage 1, they scaled up to a more capable model and gave it a bit more data to see if it could learn the complex reasoning patterns more effectively. All right, get ready for the reveal because the results were not at all what you might expect.
The outcome is really a tale of two very different metrics. One of them looked like a failure, and the other was a mind-blowing success. So at first glance, the results looked pretty disappointing. The AI only managed to follow the strict 6-part formatting rule correctly about 40% of the time. It would miss sections or mess up the headers. By this measure, you'd say the experiment was a partial failure. But
Then look at this. When the researchers ignored the messy formatting and just looked at the final answer, at the actual reasoning, the AI got it right 100% of the time. A perfect score. So even though its handwriting was messy, its logic was absolutely flawless.
And the implication here is profound. The AI didn't just learn how to fill out a template. It actually internalized the content of the reasoning process. The Nyaya framework successfully taught it how to think logically, even if it was still a little clumsy with the presentation. So, what does this all mean for us? This breakthrough is incredible, no doubt, but it comes at a cost. Creating this kind of provably trustworthy AI, well, it involves a pretty significant trade-off. And here's that trade-off in plain numbers. A standard AI might use about 300 tokens to think through a problem. The Nyaya-trained AI, it needed over 3,000. That's a tenfold increase in computational cost. Rigorous, provable logic isn't free. And this presents us with a fundamental choice as we build the future of AI. Do we want models that are incredibly fast and efficient? Or do we want models that are trustworthy and auditable, where we can see every step of their work? For a lot of important applications, the answer is going to be the latter. I mean, just think about it. For things like medical diagnoses, legal arguments, or the safety systems in a self-driving car, you don't just want the right answer. You need to be able to see the step-by-step reasoning that got it there. In these fields, verifiable proof isn't just a nice feature. It's an absolute requirement. And that really leaves us with a final big question to chew on. Maybe the race for artificial general intelligence isn't about creating models that can just think faster and faster. Maybe, just maybe, it's about building models that can think wiser, with a provable logic that we can examine, audit, and ultimately trust.